Okay, for the other problem we're going to look at here for our example, we're going to do page 624. It's going to be number 38. It tells us in number 38 that Paul's diet is to contain at least 24 units of carbohydrates, 16 units of protein, and it says we have food substance A, costs $1.40 per unit, and each unit contains 3 carbs, 4 protein. We got food substance B, costs 90 cents per unit, and each unit is 2 carbs, 1 protein. And we want to know how many units of each food substance should be purchased in order to minimize the cost, and what is that minimum cost. Now, they didn't directly give us the objective function this time, but the giveaway is really the last part of the question. What are we trying to minimize or maximize? That leads us to the objective function. Okay, we want to minimize the cost, so that means that cost is going to be our objective function. Okay? And in this particular case, we have 2 different food substances here. We have food substance A and food substance B, and the cost of A is $1.40 per unit. So it's $1.40 times A plus 90 cents times B. Okay? And that right there would be our objective function. So when we determine how much of A we need and how much of B we need, okay, based on the diagram that we're going to draw here in a minute, just like the last problem we did, we're going to be able to plug the A and the B in that are from the corners of the feasible region, and we're going to see which one's the smallest, and that's the one we're going to go with. Okay? Now, let's go ahead and get to the other part, which is we need to, from the context here, we need to be able to write the constraints, and this is ultimately the most difficult part to practice. Is from this wording, can we write down inequalities? Now, the first thing I want to write down, and I usually start with this, is the fact that A and B have to be greater than or equal to 0, because it wouldn't make sense to have a negative amount of food units here. So I would do that first, and then in terms of my drawing, I'm going to go ahead and draw just a first quadrant here of my coordinate plane. Alright, and then the 2 parts that we're given here, we have 2 more pieces of information basically, and one's about protein and one's about carbohydrates. Okay, so let's talk about the carbohydrates first. It says that his diet has to contain at least 24 units of carbs. Okay, and food substance A, okay, provides 3 units of carbs. Okay, so 3 times A, and then 2 times B. Okay, that has to be greater than or equal to 24, because it says that the total carbohydrates, okay, from these food substances that we're going to eat have to be greater than or equal to 24. Okay, notice this is a greater than sign this time, unlike the last problem we had, it was a less than, which meant it was below the line. As you can imagine, this is probably going to be above the line. Okay, we'll see that when we graph. And then if we write a protein equation, the protein equation, we get 4 units of protein from A, 1 unit of protein from B, and that has to be greater than or equal to 16. So those right there would be our constraints in this particular problem. Again, we already know that A and B greater than or equal to 0 is going to give us the first quadrant. And then for these 2, let's go ahead and make an XY chart for the first one. In this case, it's going to be an AB chart because I chose to use those variables instead. You don't have to use A and B. You could still use X and Y if you want to. That's up to you. And if I put a 0 in for A, I'd get 12 for B. 0 in for B would give me 8. So if I plot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12, 0, or 0, 12 that is. 1, 2, 3, 4, 5, 6, 7, 8. And that right there would be my line. And if we do shading this time, if we put 0, 0 in here, it's going to say 0 is greater than 24, which is false. So that means we'd shade the opposite side of the origin. So that means we're going to shade everything out here right now. So keep that in mind. We'll make an XY chart for the protein equation. 0 for A is going to give me 16 for B. 0 for B is going to give me 4 for A. And so if I go 1, 2, 3, 4 more up here, and then 4 here, and I draw those 2 together, I'm going to be here. And once again, 0, 0 is going to make that sentence false. So therefore, we're going to shade the upper side of the line, if you will. And so if we put all that together, then wouldn't our feasible region, and I'm going to extend that a little bit, wouldn't our feasible region be ultimately this? Okay. And so hence, what are the corners of the feasible region? Okay, they are this point, and this point. Okay, there's no other corners out here because that continues on forever. True? Now, as you can imagine, if we plug these three numbers in there, they're not going to give us a maximum this time, because couldn't I put a number that's way out here and get something way bigger? Certainly. But remember, we're not after a maximum here, are we? Okay, we're after a minimum cost. So this time, we're going to take these 3 points the same way we did the last one, and we're going to plug them in to the objective function and see which one gives us a minimum, and that's going to be our answer. Okay? And so the problems, they work exactly the same way each time. Okay? Sometimes we might be looking for a region that's down here, and we're looking for a maximum. Sometimes it might be out here, and we're looking for a minimum. Okay? So let's go ahead and put them in there. So we got C equals 1.4 times blank and 0.9 times blank. Let's do the bottom one here first. We said that this was the 0.80. So if we do 80, and we do 1.4 times 8, we get 11.2. So 11.2 so far is our minimum cost. But if we do 1.4 times blank and 0.9 times blank, and we do the other one up here at 16 this time, so 0, 16. If I do 0.9 times 16, I get 14.4. And we can see that that's not the answer because that's not smaller than 11.2. And then finally, we can do 1.4, 0.9, and then find the intersection point between these two lines. And once again, it's totally your choice to decide how you want to do that. You can do it with matrices, substitution, elimination, completely up to you. I'm going to do it with matrices again because I like it that way. So I'm going to edit my matrix 3 and 2 and 4 and 1. And 24 and 16. I'm going to do matrix A inverse times matrix B. Turns out to be 1.6 and 9.6. So if I do the math on that, 1.4 times 1.6 plus 0.9 times 9.6, we get 10.88. Okay. And ultimately that is lower than the 11.2. So that means our minimum cost then would be 10.88. And I believe the units here are dollars, right? So it would be $10.88 would be the minimum cost. And to do that, we'd need to have 1.6 units of the A type of food and 9.6 units of the B type of food. Okay. All right. Questions on that process? Okay. All right. So like I said, it takes a little bit of practice here. You do have a couple here in your Math Excel homework. There are 3 more problems, as you can see on this page 624, 2 of which are odd. So I would suggest to make sure that we're good at this, to practice those 2 as well. Okay, I won't collect them obviously, but if I were you, I'd probably do those 2, just to make sure I have this down pat. Those can be questions we can ask tomorrow also. So not only the Math Excel ones, but if you want to try those, especially 37 and 39, because you have the answers, you might want to try those 2 and ask those as questions tomorrow too if you have trouble finding the answers and getting them right. Okay.